In this video, we're going to be simplifying expressions using the even-odd properties of trigonometric functions. But let's first talk a little bit more about what even and odd trigonometric functions are. Now recall that a function f is even when we have f of negative x gives us f of x. And a function is considered odd when our f of negative x gives us a negative f of x. So if we suppose that t is a real number associated with a point on the unit circle, let's call it xy, then negative t is associated with the point x comma negative y, so q, point q, as we see here in our diagram. Now notice that the cosine of negative t is the same thing as the cosine of t. Right? So the cosine of t and the cosine of negative t are the same. They're both x. And so that's going to tell us that cosine is an even function. Now sine, on the other hand, if we take a look at sine, the sine of t and the sine of negative t, we get a negative sine of t, right? Because we get the negative y. So that means that sine is going to be an odd function. So what does that mean for tangent? Now, if we take a look at tangent, the tangent of t, right, is supposed to be our y over our x. So the tangent of negative t is going to end up being negative y over x. And so we're essentially seeing here that the tangent of t equals the negative tangent of t, meaning that this is also going to be an odd function. So the functions secant, cosecant, and cotangent carry the same even and odd properties as their reciprocals, cosine, sine, and tangent. Let's take a little bit closer look at that. So here in this chart, it makes it a little bit easier to kind of see that sine and cosecant are reciprocals of each other, and they're both odd. Cosine and secant are reciprocals, and they're both even. And then tangent and cotangent are also reciprocals, and they are both odd. Let's go ahead and let's do an example now. All right, so again, we only have a few even functions, and we've got quite a few more odd functions. So we're going to be simplifying expressions using even and odd properties of our trig functions. So our first property is 4 times the cosine of theta plus cosine of negative theta. All right, so what do we have? So what we have here is that we can say that this comes out to 4 times the cosine of theta plus cosine theta, because we know that the cosine of a negative t actually just gives us the cosine of t, which is kind of what's happening here. Let's write that in blue so we can see that happen. Cosine theta. So really here, I have 5 cosine thetas. Our second property, not property, but expression, is that the tangent of negative 3t minus the tangent of 3t plus pi. So here, what we're going to notice is that tangent is considered an odd function, right? Which means that we're going to have, if we have a negative t in there, that negative sign is going to come on out. So here, we're going to end up having negative tangent of 3t minus our tangent of 3t. So why did this just change to a 3t? Well, the period of a tangent, remember we talked about that in an earlier video, that the period of tangent is pi. Therefore, I can say that the tangent of 3t plus pi is just the tangent of 3t. So if I have a negative tangent of 3t, I'm subtracting another tangent of 3t, that's going to give me negative 2 tangent of 3t. So even and odd properties can be really helpful when you're simplifying trigonometric expressions.